Hello. Today we're going to do the experiment for forced convection. Okay, firstly, switch on the switch. Then the power supply. And on the heater power. Next, we will set the airflow by setting the fan speed to 3 meter per second. Okay, next we will set the airflow by setting the fan speed to 3 meter per second. Okay. And then we set the heater power to 30 watt. Then we will wait for the temperature to stabilize. So then after that, after it's stable, we can take the reading for T1, T3 and T2. Okay. And then insert the probe tip to the first port and touch the fin. And then take the reading. Repeat the procedure until 6 volt.
After we record the 6 volt temperature, then we change the pin to pin. And switch off the heater. And somewhere. Switch off the main switch. Then we change pin into pin.
connect the heater cable and thermocouple. After that, turn on the main switch and turn on the power. And last, repeat the procedure same as fin surface.
Assalamualaikum warahmatullahi wabarakatuh. Today I'm going to present about the force convection experiment for the BMMH3553 subject. So our lecturer's name is Professor Madya TS Dr. Mohd.Zain bin Hassan, and our group member is Muhammad Aiman Bin Rosli, Muhammad Aqil Aiman bin Abdul Manap, Nurul Fatihah Akmar Binti Mohd.Zain, and also me, Muhammad Nazrin Bin Baharudin. So here I'm going to talk about the objective of the experiment. The experiment is to show the temperature distribution in form of gradient along the pin or fin heat transfer surface in both free and forced convection.
Hello sir, this is the result for our experiment. For heat transfer surface, this one is spin surface. Power is 30 watt and the air velocity is 0 meter per second. So for the probe temperature, TP, there are no significant change in the probe temperature, which 23.9 from position 1 to position 4, but it decreased to 23.8 for position 5 and 6. For the surface temperature, TS, the temperature slightly changed, which is for position 1 39.7 and 38.0 for position 2, 35.3 for position 3, for position 4 is 34.5, 36.0 for position 5 and 37.0 for position 6. The inlet temperature is quite the same, which 34.3 until position 3 and 34.4 for position 4 and 34.6 for position 5 and 6. The difference in temperature slightly changed, which is mainly negative 10.4 from position 1 to 3 and negative 10.5 for position 4, and for position 5 and 6 negative 10.8. Okay, this is the heat transfer surface for fin surface. The power is 30 watt, the air velocity is 3 meter per second. So the probe temperature slightly changed. For position 1 23.5 and increase a bit for position 2 23.9. For position 3 23.8. For position 4, 5 and 6 it's 23.6, 0.5 and 0.4. So the surface temperature also changed a bit. For position 1 is quite high, it's 32.5, but it's decreased 30.1 for position 2 and continue to decrease until position 6. The inlet temperature is quite the same, which is 34, which have only different decimal numbers, and the difference temperature is for position 1 is negative 10.4 and position 2 and 3 is negative 6.4 and 6.5. For position 4, 5 and 6 is negative 10.8, negative 11 and negative 11.1.
chart of temperature, which is vertical axis, against probe position along the pin of fin at free and forced convection result. For first graph, which is free convection pin surface, the graph is directly proportional, which is probe position and temperature difference. So we plot, and last we find the nilai of gradient. Also same with free convection, but this graph is forced convection. We use pin surface also, probe position and temperature difference. We plot and we find the nilai, we find the value of gradient. Also the graph proportionally or directly proportional. Calculate and compare the difference in gradient between free and forced convection for each surface. Gradient for free convection pin surface from the equation deducts from the graph, which is y equal negative 0.0943x minus 10.22. So the gradient m equal negative 0.0943. So we move to next, gradient for forced convection pin surface. From the equation deducts from the graph, which is y equal negative 0.5886x minus 7.34, and the value of gradient is negative 0.5886. From both graph, gradient for forced convection using pin surface is higher than free convection using pin surface. In forced convection that has velocity of 3 meter per second because of presence of fan, while free convection that has no fan has velocity of 0 meter per second. From that, we can deduct that gradient can be affected by type of heat surface and also velocity value. The temperature difference is inversely proportional to probe position. As the position of surface is further, the temperature difference become decreased.
Assalamualaikum. My name is Muhammad Aiman. For discussion number 3, the question is, what can you say about the difference? Which type of convection give better spread of temperature along the external surface? So the answer is, as fluid motion happen in free convection as effect of change in density of fluid after heating process, whereas it also happen in forced convection as the presence of fan as external sources. Presence of external factors such as fan will give impact in forced convection. Because of this, heat transfer coefficient in forced convection is large and helps better temperature spread through expand area compared to free convection. And because of this, gradient in forced convection for pin or fin surface lower than free convection. For discussion number 4, the question is, the external surface is made of stainless steel, which is relatively poor conductor. How would using aluminium or copper better conductor affect the temperature gradient and the overall efficiency? So the answer is, the gradient for temperature will be reduced while the overall efficiency, that is convection heat transfer efficiency, will be increased when using aluminium or copper and items that have better heat transfer efficiency properties. Better conductor material increase the rate of heat transfer. The convection of heat transfer coefficient also can be improved by adding external factor such as fan or adding the surface area to be more larger.